Okay, good evening all. So in the last class we were looking at structures. I told you how to declare a structure, define a structure. First define a structure, then declare some struct variables, and then initialize them. Right? We looked at each one of them separately and also methods in which we can combine two or more of them. Okay, and I also told you that we can give an alias to a structure, right? Type def struct student student. So here student becomes the alias for the entire struct student. So rather than using struct student every time, you can just say student. It will understand it as struct student. Okay. And then using that, you can declare variables like int xy. You can say student s1, s2, and so on. So either you can first define the struct and then write this line separately, or while defining the struct itself, you can use type def operation so that it gives a name to the struct apart from the definition. Okay. And I also told you that we can use structures inside some other structures, right? So we defined struct points p1, p2, and then we defined a slightly higher order struct called line segment whose members are struct points. Okay. Um, yeah. And then I told you how we can declare an array of struct points. The way, if I have to declare an array of 100 integers, I say int a of 100. Similarly, if I have to declare an array of 100 struct points, I will say struct point a of 100. Okay. So here, each element in this array is a struct point, right? And all the members of this array, all the members of each of these elements can be accessed as a of I dot x, a of I dot y, right? Because each element is a struct point and struct points members are x and y, int xy. And if it were normal struct point, say some name, struct point p, then I access its members as p dot x, p dot y. But here there is no separate name for each element of the array. I access that element using the array index a of 0, a of 1, etc. Okay. So if I have to access the elements of a of 0, I will say a of 0 dot x. I can assign some value, whatever, some 5. A of 0 dot y equal to 10. A of 1 dot x equal to -1. A of 1 dot y equal to 0, something like that, right? So each element I can evaluate like this. I can give a value to it like this, and also I can use it in any expression. Okay. Now, how to use a structure in a function? Okay. Before that, one good thing about structures is copying from one structure to another is much easier than copying from one array to another. So suppose if I have struct point p1 equal to something 1 comma 2, and I say p2. All right. Now I want to copy p1 to p2. Okay. One way is I take each member of p1 and I copy it to each member of p2. So I say p2 dot x equal to p1 dot x, p2 dot y equal to p1 dot y, and if any other members are there in p1, I copy all of them. And if the structure is more complex, if it has like struct student, like we saw, it has some name, id, age, all those things, then again I need to take each member and copy each member from that struct to this struct, the values. But you need not do all that. You can simply say p2 equal to p1. No matter what the members of p1 are, all those members with all their values will be copied to p2. Okay, even if it has strings, even if it has arrays, even if it has normal primitive data types like int, char, etc., all of them will be copied to p2. Okay, so you need not worry about copying member by member, and copying for array you copy in one way. You have to use a loop to copy each element from this array to that array, right? You need not worry about all this. Okay, so copying one struct to another struct is quite easy. It's like any primitive data type. If I have to say, if I have to copy integer x to integer y, I just say y equal to x. Similarly here, p2 equal to p1, as simple as that. Now because of this, structs are usually called by value when you give them as arguments to a function. Okay, suppose I define a function called converse, which takes a struct point, say p, and it returns a struct point. So what does this function do? It just takes p and reverses the sign of its members. Both its members are integers. If they are positive, it will convert them to negative. If they are negative, it will convert them to positive. That's all. So all it needs to do is p dot x equal to minus p dot x and p dot y equal to minus p dot y. Return p. You remember earlier while discussing arrays, I said you cannot return an array. You can only return an array pointer. And you cannot return more than one element. You can't return x comma y. You have to return either x or y. In this case also, you're not returning two things. You're returning only one thing, but that one thing has many things inside it. So if you want to return more than one thing, which are of different data types, then one way is to create a struct type and put all those different data types inside this struct and return this struct. Okay, so you can return only one thing at a time. You cannot return more than one thing in any function. That's it. Here also, technically you're returning only one thing. This entire thing is a unit. It may have many members inside it, but it is still one thing. Okay, so now if I want to call it in my main, I'll say, so I'll not use struct point every time. You assume that I have defined my struct and I have also used this type def command. So I will just call it point. Okay, so I'll say point p1 equal to 1 comma 2, and suppose if I print p1 dot x, what will it print? 1. If I print p1 dot y, what will it print? 2. Okay. Now I call the function converse. What should I pass to it? Where is p? p1, right? You need a variable of that type. You need to pass that variable. Here the variable of type struct point is p1. Okay, so I say p1. Now if I print p1 dot x, what will it print? Minus 1. Why should it print minus 1? But what am I passing? I am yeah, that's okay. How am I passing? Am I passing using call by value or call by reference?
Call by value.
Call by value. So if I pass it using call by value,
It does not give a value.
so then now if I print p1 dot x, what will be the output? 1 only. So although I am passing this struct point p1, this is passed by call by value. So it will create a copy of it and change only the members of the copy, not the original. So the copy's members are changed. That will not affect the original. So when you come outside the function, the original remains the same, right? So p1 dot x will still be 1 and p1 dot y will still be 2. But suppose now this function is returning this p. Okay, it is changing the copy and it is returning the changed copy. I can store this copy in my original variable and override my original variable. Okay, so what I can do, I can say p1 equal to converse of p1. Now this will be overridden with the changed copy. Okay, now if you print p1.x, it will be -1. If you print p1.y, it will be -2. Okay, so this is still not call by reference, it is still call by value only, but you had an option of taking that value from the function and storing it somewhere. But sometimes you don't have that option. You have to change it within the function. You can't return anything. In that case, it is call by reference. We will see that example. This is clear? Okay, so to look at call by reference, to do call by reference, what do we need? Pointers. The way we have integer pointers, char pointers, whatever, we also have struct pointers. Okay, so if I want to define a struct point star, so I need to write I'm assuming I still have the type def thing, struct point as point. So I will just say point. Okay, first, normally, how do we declare a pointer to an integer? We say maybe say int x equal to whatever, 3. And then I say int star p equal to %x. Right? Same thing here also. First, you declare a struct point p equal to maybe 2, 3. Okay, and then you say point star ptr equal to %p. That's it. Here, what do we mean when we say x equal to 3 and there is a pointer to it? So we have some memory for x, it has a value 3, and then I have a pointer p pointing to this. Okay. Similarly, when I say point p equal to 2, 3, here what it means, there is some cell whose elements are 2, 3 and its name is p, and I have a pointer pointing to this location. Okay, that's all. So now if I want to print these values, one way is p1.x, p1.y. Okay, but if I want to print them using the pointer name, now there are two things. One is the data type name, another is the pointer name. You can access the values of the data type using either the data type name or the pointer name. Okay, normally we know how to access members of any struct using its name, the dot operator, p1.x, p1.y. But if I want to access them using the pointer name, I cannot write ptr.x or ptr.y. I have to write ptr arrow x and ptr arrow y. Okay, fine. So you cannot use the dot operator if you have a pointer pointing to the struct. You have to use arrow operator. Okay, so this is something which you need to keep in mind. Now let's so what this means is, this is same as star ptr dot x. That's all. That is why this works. So this will be converted like this. Star PTR is P dot X. Okay, yeah, good question. Okay, so both are equal, fine. All right, so now let me modify my converse function slightly to pass struct pointer instead of a struct. Okay. So what I'll say struct point star P. Okay, so now P is not a struct but a struct pointer. All right, so here what should I write? P arrow X equal to minus P arrow X. Put brackets just to be safe, so that you ensure that it will follow the order which you want, even though it might follow the order which you want without brackets also, but you don't know. So just keep brackets just to be safe. Similarly, P arrow Y equal to minus P arrow Y. Do I need to return anything? Huh? Should I return? You don't need, you have changed them. You have changed the original members. So even if you leave the function, that will anyway be reflected. So you need not return anything. Okay, that's it. Now, in my main, I can say struct point p1 equal to 2 comma 3, and I say point star. I can say struct point or point, anything is fine. Point star ptr equal to ampersand p1, and I call converse of, what should I send as argument? Right. I can either say PTR or I can say ampersand P1. And if I want to say ampersand P1, then I even need not declare PTR. I can directly pass ampersand P1. That's it. Okay. So now if I print P1.x, what will be the output? Minus 2. Yeah, because this original thing will be changed. That's all. P1.y will be minus 3. Okay, that's it. All right. Now, you see, later when you deal with linked lists, you will deal with a chain of nodes which are which cannot be accessed using any index, because all these nodes are not stored in contiguous locations. When you have index, an array, the index can be converted to an address. You remember, it's like a of I is nothing but star of a plus I. That is because they are all in continuous locations. But linked lists are not in contiguous locations. That is, so we have RAM. So suppose I want to create a series of variables. Suppose I have too many variables and there is no one place in RAM where all these variables will fit. Some of them will fit in one location, some of them will fit in another location, something like that. Okay. So the way variables are stored will be like out of order. Like say x1 is stored here, maybe x2 is stored here, maybe x3 is stored here, and x4 is stored here. Okay. Now, how do I know where, suppose I know where x1 is, but how do I know where x2 is? And how do I know where x3 is, right? The only way is each of these locations has some address. Okay. I have to store the address of that variable also in the, along with the previous variable. So I will not store just a variable, but I will store a variable value and the address of the next variable, so that from this variable I can reach to the next variable. At that variable, I will store the address of the next variable. So I will create a chain like this. Okay. So this chain can be arranged in any way in the RAM, but I always have a link to every element of this chain if I know the address of at least the first element, because from there I can pursue the chain, other members of the chain. Okay. So here it will be like ampersand of n2. So why I'm calling n2? Because this entire thing is a node. Okay. So n2 means here I will have address of n3. Here I will have address of n4. And this, assume this is the last node in the chain. I will just say this is null. Okay. Which means, so since I have address of n2, this will be pointing to this location. And here I have address of n3. This will be pointing to this location. And here I have address of n4. This will be pointing to this location. And since this is null, this will be pointing to null. Basically, this is not pointing anywhere. Its value is null. Okay. Yeah. So this will be my linked list. Okay. So here each element in this list is not a simple variable. It is a struct with two values, where one value is an integer and another value is a pointer to the next node. So these two elements constitute this struct. All right. So such a struct will look like this. Struct node int x, and here the second element is a pointer to another struct node. Okay. Whether it is the same struct node, another struct node, that's a different thing. But the type of that element is, it is a struct node pointer. Right. So here I write struct node star. I will call it next, just to say it is pointing to the next node. Okay. That's it. And I will give it a alias called node. Okay. So in my main function, what I will do, I'll say node. So here I can do two things. One is I can say node n equal to, I won't say equal to, I'll say node n, and I can say n dot x equal to something 10, and I can initialize n dot next equal to null by default. Okay, that I can do. Then what will happen? It will create a node with value 10 and this pointing to null. This node name is n. Fine. I can create another node, node n2, where n2 dot x equal to 20 and n2 dot next also equal to null. All right. So here another node 20, this is n2, this is also pointing to null. Now what I want to do is, I want this pointer to point to this node instead of null. I want n next to point to n2. Okay. So that I'll get a chain. I can continue doing like this. I'll get a chain of nodes. Fine. But yeah, I can do that. So what I need to do, I need to write n dot next equal to, now you see, this is a pointer to a node. All right. The second element in the struct node is a pointer to a node, which means it stores the address of a node. All right. Which means suppose n2 has some address, something, some 100 is the address of this node. So what I want to do is I want to store that 100 as the second element. That will automatically make it point to this node. Okay. So what should I write here? Exactly. N dot next equal to ampersand n2. This will make it point to the next node. And if I create n3, I will say n2 dot next equal to ampersand n3. If I create n4, I will say n3 dot next equal to ampersand n4. Okay. This is one way. But then I don't want to, I don't know how many nodes I will create. I don't know. I don't want to name each node. I don't want to name every element in this linked list. I don't want to worry about that. Okay. So usually in linked list, we don't create, we don't name every node. All right. So what we do, we directly deal with node pointers, not node names. So there are two ways. Even in integers also, even without using the variable name, you can directly deal with the value using the pointer. In the previous case, what did we see? We saw there are two things: variable name and pointer to that variable. So you can access the value of the variable either using the variable name or pointer to the variable, whatever that variable is, whether it's an integer or a struct. But in linked list, we don't worry about variable names or node names. We will directly deal with pointers. Okay. So you need not worry about naming every node. All right. Like here, I can access X using PTR arrow X. I don't even need P1. But the only reason I needed P1 is for PTR, I had to map it with ampersand P. But if I can create a PTR without ampersand P, then I don't need P. I can access its members using the pointer name itself. Okay. So how we do that? That we do using malloc. Okay. So suppose I want to create a node. One is I first create the node using its name, like struct node n, struct node n1, struct node n2. That is one way. But I don't want to use names. So I just want to allocate some memory to a node, and I want some pointer to point to it. Fine. So I use malloc. And what is the argument for malloc?
Size of
In this case, it's struct node. Okay. So it is size of, I don't know what is the size of that node. I mean, I can calculate, but I need not worry about that. If it has some integer, some character, something else, then I need to add all these elements sizes and then get the size. But I need not calculate the size and give. If I just use size of function, it will calculate and allocate sufficient memory to me. Okay. So I'll say size of, I can say size of node if I have type def, or I can say size of struct node. Okay. And here I will say node star, whatever, let me call it head, the head pointer to the first node equal to this malloc. But before this, I need a type conversion. Yes, very good. So I can say struct node star, I can say node star. It usually malloc returns void star. I have to convert it to the type I want. So I am converting it to node star. Okay. So now what happens? This will allocate some memory to a node, Okay, its values are not yet fixed, but its size is sufficient for you to initialize those values, and it will return a pointer which will be stored in a variable called head. So this will be my first node in the linked list. Now, whatever new nodes I create, I will uh, put it as my head next. So currently what I will do, first I will say head. Now I have to access its members using arrow operator. I cannot say head dot x because head is a pointer to this node. Head is not the name of this node, right? So I'll say head dot x equal to something, say 5, and I will initialize it to head next to null. Okay, so say this will be mapping to null. Now what I want to do, I want to run a loop where say I want to create a node and make it head next. Say that is the second node. Now I want to create another node and make it the next of the second node. Then I want to create a node and make it the next of the third node. Okay, so what I'll do, I will say some temp also to be pointing to this. So first I will say temp equal to head. All right, and now while, or because I want to create some 5 nodes, say 3 nodes. Okay, I'll say for I 1 to 3 temp next equal to a new node star malloc size of struct node or node, anything is fine. Okay, so it will create a new node and it will assign that node to my temp next. Okay, so first this now temp is this, you can either access it using head or temp. Okay, head next is this or temp next is also this. I will override this null with the address of the next node, so this will be pointing to the next node. Okay, you can initialize so now what you do, you say temp equal to temp next. So now temp will move from this node to this node. Okay, now you initialize the values. Temp x equal to, say it is I, just because you want to automate that value, and say temp next equal to null. That's it. So first it will create one node, map it to the previous temp next. Okay, now in the second iteration it will create one more node, map it to this temp next, and then move this temp here, right? And make this this initially this temp x is I. In the first iteration this is 1. Now temp x is in the second iteration, so this will be 2, and this temp next is null. In the third iteration it will create a new node and change this null to point to this new node, and then it will move the temp from this node to this one. This will be 3, this will be null. Okay, so I can create a chain as long as I want. Now you don't need a name for every node. You don't even need to know the location of every node. You need to know the location of only the first node. From there you will know the location of second node. From there you will know the location of third node. From there you will know the location of fourth node. So they can be stored anywhere in the RAM. It doesn't matter. All right, so this will be useful to create trees, right? Because trees can't be stored in contiguous locations, graphs can't be stored in contiguous locations. So now you can create more complex binary structures, more complex data structures. Okay, so this is useful for data structures. Okay, so actually fine, this is done. And one more thing here, if you notice in this struct node definition, we created struct node star next. Okay, this is a struct node pointer. But if you want to have struct node itself as a member, that is not possible. No structure can have itself as a member, because that is like a circular definition, right? You're trying to define a struct. If the definition of struct involves itself, that definition is never complete. It is begging the question. So a struct can have other structures as members, or can have a pointer to itself as a member, but it cannot have itself as a member. That will lead to an error. Okay. So you cannot have struct node as a member of struct node. You cannot have struct point as a member of struct point. Okay. That is something to keep in mind. Yeah. And then one more thing. Suppose if we have, okay, so now I will get into some general things which I want to cover. We are done with structures. Any doubts? Okay. So suppose if I have some character array, and suppose I'm giving a long string. This is a very long string, something. Okay. Now, how many characters it has? One is we need to count. Another simple way is to know the size of this array. All I need to do is, I should say, size of A divided by size of, either you can say the data type, or you can say size of A divided by size of A of 0. This is true for any kind of array, integer array, character array, float, struct, whatever it is. So to know the number of elements in the array, you can divide the entire array size with the size of one element. In this case, character is 1 byte, so that's fine. But in integer case, it will be 4 bytes. In struct case, it can be anything, right? So this is one way of finding the size of an array. If you are giving all the elements during the array declaration itself, if you are initiating the array during the array declaration itself, if you are not initiating it during array declaration, then you cannot use this anyway. You need to know the size, and you will declare the size. You will use the size to declare the array, and then you will run the loop, right? But if you are declaring, if you are initializing during declaration itself, to know the size, because you're using empty brackets, you're not using the size. So you can infer the size from the value. All right. So this is one thing. And then now, yes, we have an array. Suppose we have an array of what do we say? Suppose we have an array of struct, or we have some 100 integers. Fine, a simple array of 100 integers. Now I want some values for this array elements. Okay. One way is I link it with index somehow. A of I equal to I, or A of I equal to 2i. Some formula I can link with I. But I don't want any particular number. I want random values. Okay. In that case, we have something called a rand function. So suppose if I say print printf %d rand, it will print some random number. Okay. The range of this random number varies from system to system. It varies from 0 to minimum 32,700 something. It can be bigger than that also, but minimum it will be 32,700. Okay. So let's check it by typing. So let me I'll say printf %d. Okay. So actually, to use rand, you need to include another library called stdlib.h. Okay. So the warning is gone now. So it is printing some random number. Fine. Suppose I put it in a loop. I don't want just one. I want some, say, 5. but these numbers seem too big. For my purposes, I can define a range, right? Suppose I want to have random numbers between 0 to 1000 or 0 to 100. Okay. What should I do here? Huh? If I want numbers between 0 to 100, what should I do? Huh? Rand mod 100. So anything mod n will give you the result between 0 to n minus 1. So here I'll get the outputs between 0 to 99. If I want 0 to 100, including 100, then I should do rand mod 101. Okay. So here I'll get between 0 to 99. All right. Now, but the problem here is, you see, if I do it again, same values, again, same values, again, same values. So there is no randomization now. It's only one time, but I want every time. Okay. Then what to do? So then we have something called SRAND. SRAND means every random number generator. Technically, there is no ideal random number generator. There is no true random number generator, in the sense that by nature, it always generates random things, truly random things. No, it is an algorithm. It is based on some predefined steps. So no matter how much you try, it will follow that algorithm every time. So the kind of sequence which it generates is in some sense repetitive. All right. Normally what happens is, there is something called SRAND, which is like a seed function. It gives the seed for this random number generator. Based on this seed, it will generate some sequence of numbers. If you change this seed, it will change the sequence of numbers. By default, SRAND is 1. Okay. So same numbers are actually being generated. You see, same numbers, because SRAND is 1. I did not change it. I just wrote it explicitly. Okay. Now suppose if I change this SRAND, suppose I make it 2. All right, I should compile it. Numbers are changed, but again these numbers are repeating. I don't want this again. I want random every time. Okay. So for that, it's like your seed should be changing every time, right? So one way of doing it is, you make your seed a function of time, because time keeps changing. So your seed will also keep changing. So your random numbers will also keep changing. Okay. So normally it is done like this. Now it will ask for time library. So you include time.h. Okay. Now you will get different numbers each time. You see, here we got same, but it will change. Maybe I pressed too quick, so that even before it changed, even a second, it created the same set of numbers. Okay. So you don't need to have a separate line where you link RAND with SRAND. They are by default linked. So all you need to ensure is SRAND should come before using RAND. That's all. You don't need to have an assignment operation between RAND and SRAND. They are linked. That's it. Okay. Fine. And then in there are a couple of more things which you need to know. There is something called hash define. Okay. So hash define is usually used for substituting something with something. Suppose if I want to use an operation like if A greater than B, return A, else return B. Something as simple as this. I can use it using ternary operator, right? A greater than B, question mark, A or B. If A is greater than B, I'll get A. If that is false, I'll get B. Okay. But I don't want to type it every time. It's too clumsy to type. All right. So what I will do, I will give it a shortcut. I'll say max a comma b. Okay. So whenever I want to find the max between a and b, I will just write this max a comma b. But technically, this max a comma b is not a function, and it is not being used. Just this max a comma b will be replaced with this ternary expression. So rather than typing this thing every time, you're giving an alias. This is also like an alias. You substitute this thing with the expression you want every time. So what is the difference between type def and define? Type def is used to give alias only for data types. Define is used to give alias for anything, for any expression, for anything, even a constant, even a value. You can also say hash define, maybe size to be 10. So here the idea is, whenever I use size, it will replace that size with number 10. This is like a variable only, but technically not a variable, because two things. One, you can't change this. Okay, this is like constant. It's a const variable kind of thing. I'll tell you what const variable is. The name itself tells you. Second thing, it doesn't know the name size. Basically, before you even compile your program, all these aliases will be replaced with their values. So these are called pre-processor macros or pre-processor commands. So what happens is, like this hash include stdio.h. What does it mean? Before your file is compiled, this hash include stdio.h will be replaced with the content of the file stdio.h. And before you compile your file, wherever you write max a comma b, so I can write int main printf %d max 5 comma 10. Okay, it will print 10 for me. Okay, but here what is happening is, max is not a function. It is not calling the function. Max is just some expression. I can replace it with some min 5 comma 10. Anything I can do. All that it is doing is, it is just replacing this max 5 comma 10 with this expression before it is compiling. So these are called pre-processor macros. Okay, so all these are substituted before your file is compiled. Fine, that is what is happening. And here, instead of 5 comma 10, I can also say 5 comma size, right? Now what it does, first in the place of size, it will put 10. Then it gets max 5 comma 10. Now in the place of max 5 comma 10, it will put this expression 5 greater than 10 question mark 5 colon 10. So that entire expression it will put, and then it will compile. But when you are calling a function, that's not what is happening. The function is called, and then it executes the statements of the function. So this is not a function exactly. It is just a synonym or just a substituent. That's all. Okay, this will also work. Same thing. Okay, and one more thing. A const variable, if you want a variable to be never changed, right, then you declare it as, you put a keyword called const before that variable name. I can say const int x equal to 5. So basically what it means is, even by mistake you cannot change x, because you see, when big projects are done, a lot of files are shared. Just a minute. A lot of files are shared between many people. So there can be some global variables which are common across files. So even by mistake, you don't want those variables to be overridden, right? So you make them const variables so that those variables are not overridden even by mistake. Fine. And another thing, when you have big projects, there are many files which are actually being used. Your program is only one of the many files which are being used. This include files which you have, the libraries. There is something called linking, something called loading. Many libraries are there which will be used by the compiler to be attached to your file, and then this entire thing is compiled. Okay, So it is not just your single file which is being handled. So all these are done using global variables, using these preprocessor commands and all those things. Okay. So here, if I say, even if I just say x plus plus, it will give an error because x is a constant. Error. You can't increase a read-only variable. That's it. So if you want some variable to be absolutely unchanged, put const before that. Okay. And then, all right. One more thing. Now suppose each of these files, every time I compile them, I'm getting only one executable name, a.out. So if I want to compile another file, if I want to check another file, again I have to compile it. I will get a.out. But if I want to go back to another file which I checked already, again I have to compile it. Again that will replace. So every time, suppose I want to continuously check two files. Every time I compile this file, that will override the previous file executable. Every time I compile that file, that will override the previous file executable. So because I'm having only one executable name. But suppose I want different executable names for different files. Okay. So for that, what you can do is gcc, whatever you want to compile. Suppose I want to compile 4.c, or I can first say -o, 4.o, and then 4.c. So basically what it does is, it compile, I'll not say 4.o, I'll say 4.exe. Instead of a.out, I will call the executable of the fourth problem to be 4.exe. Okay. Oh, I should change this, otherwise it won't run. Oh, 4, right? I'm sorry. Even in 4, I have some such line. Okay, that's the problem. So let me do it for 7.c. Order doesn't matter. Yeah, it's only a warning, unused variable. That's okay. So now you see, you have some file called 7.exe, right? So I can do /7.exe. That's like /a.out. I can have another file for 6. I can say 6. Rather than naming it 5, 6, 7, for instance, like this first problem is struct declaration and initialization. Okay. So I can name this file SDI something. Okay. So now I have a command or an executable file called SDI. Now this can be a new command in my system. You see, in my system there are many commands, right? Like I can say ls. ls means list all the files in this directory. ls is a command, right? Similarly, I can say copy 7.c to say 8.c. Copy this file to another file. Okay. So now you see there is a new file called 8.c. So all these are commands. CP is a command. ls is a command. What are these? These are nothing but executables. These are files of some C program where it is given, that program is written, it is converted to an executable. That executable is given to you as a command. You are running that command, means you are calling this executable, which means you are calling that program. That's all. So this SDI will be my new command. SDI something that will do something. Okay. Now I cannot give any arguments to my function. I didn't write my code like that. Okay. But the commands which are predefined, like ls or copy or change directory, I can say cd dot dot, which means it will go to the parent directory. You see, now these are different files. I'll say cd minus, it will go to the previous directory. Now I came back to this directory. Okay. So a command and some arguments, command and some arguments. So for this, what you need to do, so here what is happening is, there is a main function there. That main function is reading your command, and it is also taking the arguments which you are giving. cd dot dot, that dot dot is an argument. cd minus, that minus is an argument. Copy 7.c to 8.c. Here 7.c and 8.c are arguments. So even main function can also take arguments. Okay. So how does it work? Usually we call it argc and argv. I mean, these names can be changed, but first one is an integer, second one is a 2D array, which means it's a series of strings. Okay. So um, I may take just 5 minutes today because I want to complete these things. Um, so first, how many arguments you are giving when you are running the program? Like CP, 7.c, 8.c. There are 3 arguments. The command and the 2 arguments for this command. These 3 things together are arguments for the main function. Okay. And then for int I equal to 0, I less than argc, I plus plus, intf, percentage s, argv of I. Right? Okay. So let's just see this. Okay. Print. Okay. Now suppose I say dot slash a dot out. This is only one argument. Okay. So it will print one argument, and that argument is dot slash a dot out. But I can give some other arguments. It will do nothing. It will just read them and print them. Hi, hello, how are you? So there are 6 arguments. Dot slash a dot out. Hi, hello, how are you? If I choose to do something with these arguments, I can write such a program, and someone else can use this program. So the copy and CD, those files, they have their main functions, which are taking the arguments. When I say copy 7.c, 8.c, that main function there is saying, okay, if it is a copy command, take the 2 arguments and open the file with this name and copy it to the file with the second name. So all this is written in that main function. Got it? That is converted to executable, and that executable is given a name called CP. That executable you're calling every time when you say CP. Got it? So main function can have arguments. In this case, we are not writing any application, but when you write an application, this is how it is written. So most of the kernels code, any kernel code, operating system code, most of the operating system's code is written in C. Even GCC compiler itself is written in C. So when you're compiling, actually this command itself, when I say GCC 7.c -o 7.exe, so this is being given to a file which has a main function which takes these 4 arguments. It says GCC, then the 3 arguments are okay, 7.c, then -o, then 7.exe. So it will compile your file and create that executable with the name 7.exe. So that compiler itself is written in C. It has a main function which is taking these arguments. Okay, so this is what this is how you pass arguments to a main function. Okay, and last thing, you can have a chain of pointers, like we saw normally. If I say x, some value it has, I can have a pointer p. Okay, I can also have a pointer to this p. All right, it can be p2, something like that. But the type of p2 is different from p. P is an integer pointer. P2 is a pointer to an integer pointer. Okay, so for that, how do you write? You say int x equal to 5, and then int star p equal to ampersand x, and then int star star p2 equal to ampersand p. Okay, you can't skip this and directly say int star star p2 equal to ampersand ampersand x. That will not work. You can't have some 5 stars and 5 ampersands at once. No, all the intermediate steps should be covered first. You should have intermediate pointers to have a bigger pointer. Okay, so first you should have integer pointer, then integer pointer pointer, then integer pointer pointer pointer, whatever it is. Okay, and if I want to print x, I can say star p, or I can also say star star p2. both will point to X only. If I just say star P2, it will point to P. If I say star star P2, it will point to X. Okay, so this is something which you just need to know. All right, so yeah, I know I covered the later portions very fast because we didn't have much time. So you have to do a lot of hard work to catch up. All right, but you need to know these things for data structures course next semester. Okay, and these are some of the things which I thought you should know by the end of this course. All right, so let's close here.